Dave Fiak. I'm a national trainer from Wimber, Pennsylvania. With me today is Fred Crick from Oklahoma. Fred, thank you for coming along.
Welcome to be here.
So what are we going to do here today, Fred? What is your intentions?
Let's unbox this BGH96. It looks like it is an 80,000. 80,000 means that's 80,000 BTUs on high fire.
Okay. And we have two models of that, right? We have a B and C series, which means the width for an
and a D
coil.
series. Yep, absolutely. So this is the C series, and the D series is going to be wider, and the B series is going to be a little bit narrower. That way we can get it into closets and fit it where it goes. The case coil that we're going to do here in just a second also will match each one of those series of sizes and things. So let's cut this box and see what happens.
All right. Am I allowed to use a knife in Oklahoma?
You can. Just can't go to airports with that.
How about give me a hand lifting this box?
Oh,
I've seen some previous slides. These can be tough to do. Oh my.
Packaged well. There's your knee pad.
Yeah, that could be a knee pad. Wow, we got a bag of goodies here, huh?
Okay.
That's a good sign. I like when they come with bags.
I like it. What do you got in it?
A book.
All right.
We got some books. We got some grommets. We have a nipple in there with some hose connection for condensate, and we have our LP conversion kit included. So they come with the LP conversion kit.
So, wow. Look at that.
Take that off, see what we got going on here. Please keep the plastic bags away from your head. They don't do well when you put a bag over your head.
New label.
Let's see if we can take this bad boy apart and see what's goodies in inside of it. We have 4 screws going across the front. 2 are for the top. We'll take the top off first. Then we have 2 doors that hold the bottom. There are glass observation ports so you can actually look inside and see what is going on with the system. Might need a little screwdriver to get it started. There you go. I told you not to eat your fingernails.
Right.
So, Fred, on the back of them doors is some important information, I believe. I think it's the top one, gives you the actual fire rate of where you need to set your gas pressures. So all that information is located right up here. So when you're looking for pressures and applications, it's written on the back of the door. I think they're now in the manuals. The one time they weren't, but I think we now have that pressure in the manuals.
Okay.
So if you're having an issue finding it, this is what you're going to be targeting your pressures when you hook up the manometer to read gas pressure setting that up.
So whether it's natural gas or propane?
It's all written there for you.
Okay.
I'll put those screws back here.
Now what happens if I'm setting this above 2,000 feet?
So what you got to do is you have to change the orifices for a higher elevation. They have different numbers. As we go higher in elevation, the air gets thinner. There's less oxygen.
Okay.
So we need to cut back on the gas amount. Otherwise, we'll run too rich and create carbon and
there we
carbon
go.
monoxide.
Okay.
So we are very specific. Typically, we'll go up to 2,000 feet on our elevations for what comes in the kit.
Awesome. Okay.
Okay. Cool stuff. So let me see if I can get the bag opened up more here, because there's a couple things I want to highlight in the bag. What's that hose in there for, Fred?
It looks like we've got some drain hoses, and being a 96% furnace, this is going to be a condensating furnace, so that means that we're going to wring some moisture out of the secondary heat exchanger, and we're going to make water basically in the winter time, so we're going to have to get rid of that water. And these hoses now allow us to go into this pre-made trap. Get this out of the bag. Got a self plastic made or trap with the framework in it.
So guys and gals, when you're doing your traps, you want to put the trap, if you can, to the side of where our outlet connection is. On this particular one, the outlet connection is versed over here on our left-hand side as I'm facing the camera. So trap works best here if you can do that. If you can't, you can put it here. The issue that's very critical is our elevation, left to right, has to be level. If it's not level, if it's leaning just a little bit one direction or the other, the water will not run out of that into our trap, and it'll be plugged with this hose. We have 5/8 of an inch of fall coming from here to the connections over here. 5/8 is not a lot to have a little deviation on our slope.
And one of the things that I see that's nice about this is that I now have the template to which direction I am wanting to exit this, and also if I'm laying it down horizontally, I now can take this template and cut the hose off, and I don't have to guess at that particular scenario and get it wrong and have to go purchase some different drain hoses. So that's pretty nice.
Yeah, on the earlier versions, we had some issues with how that hose was ran and how tight it was.
Oh, yeah.
If you had too much, it would give you issues with traps. So I'm unwrapping the conversion kit. In our conversion kit, they usually send 4 nozzles, 4 orifices, sized for LP or for natural. These always come stock as natural gas. So out of the box, they're set for natural. If you want to convert to LP, you're going to have these 4 nozzles. It's usually pretty easy to do before you hook up the gas line at that point. We can usually pull these 4 screws here, roll the manifold back, change the 4 orifices, or 3. This is a 4 orifice, it's a 4 tube, and put it back in. You don't have to pull off all the wires and all the connections. You usually can roll them back if you have to.
So I don't have to ask the distributor for the propane kit. That came with it.
It came with it.
What
unless you're over 2,000 feet.
And then we have to...
Yeah, then we have to go that.
Yeah.
So guys, in my hand are the springs. This was a topic of major concern a while back. But these springs in the early days would come wrapped up, almost like it is now, Fred. It almost looks like there's only 1 spring there. But there's actually 2. And you have to untwist them springs. So in the early days, we get people calling us about, hey, I only got 1 spring.
Right.
And when there was 2 actually there. So you have to physically untwist them, but there's actually 2 springs there for that process. We got an LP conversion kit tag in here that if you're going to put the LP, it gives you cautions with that, LP labels. So when you make this LP, you want to make it very obvious that it is. Our slope, recommended front to back. Guys and gals, this is our condensate drain in here. This has to flow out of here very easily. This is very acidic water. And our rationale for having a slight slope, if our acidic water sits in that stainless steel heat exchanger for any length of time, it can eventually eat through that process. So we're going to suggest to you a 1/2 inch to 3/4 of an inch of slope, something like that. Just ever so slight. Now what happens a lot of times, people have heartburn when we do that because our ductwork now is going to come off at an angle. With anything that we do with air, we should have canvas collars involved. Canvas collars is not for a misalignment, but for sound attenuation. We don't carry that noise through the home or through the ductwork. Okay. So we can always favor that a little bit with we can bring our ductwork down straight and let the canvas collar make that little bit of a goof up or mess up on that process.
Okay. So I noticed that being the 96% furnace, I'm not venting it out with Class B vent pipe, metal, and all that kind of thing. So we're now using PVC pipe?
Correct. And we're able to do that with PVC pipe in our application. We have 2 ways of going. We can take air out of our basement or out of our home and put it in this. We have to have an 18-inch pipe and an elbow. And the rationale is that we don't come in and have someone set down such as this, perhaps, over top of that and eliminate the air input.
Yep.
So they want to keep that process going. There have been some cases where I've been involved with people having issues with the furnace lighting. When the furnace is having issues lighting with a single pipe system, depending on the negative pressure that's coming into the home, coming from our vent pipe, we can be pulling air from outside into the chamber and into my home. And so this blower has to overcome that reverse pressure coming in. Sometimes in attics, if these are vented into an attic or installed into an attic and you have a fresh air intake coming out of the attic, that ridge vent, when it gets warm up there, pulls a lot of air up to that attic, and you got a lot of negative pressure being pulled through here that has to overcome. A lot of times you're better off if you can to put 2 pipes on that system, run them both out the east wall, both out the west wall, whatever side you're on, not on opposite sides, so we don't get the air blowing through that unit.
So this pipe is actually for my air that's going to be for my combustion.
Correct.
This is the bad gas going out
Correct.
Okay.
Yep, and if you take a look inside, there's nothing here. We're going to use that tool. It goes right in that chamber. There's no pipes in there. This is just your fresh air intake. That makes this a sealed compartment that we're not pulling any air out of your living space for concerns.
Wow, okay.
This one here is going to go into it. You can't see that's going into our blower.
So this is a 3rd generation Bosch furnace, and with this particular furnace, the IOM is going to state that I can take the bad gas, take the combustion air, basically into a concentric fitting, going out and exiting the structure in that concentric fitting. We couldn't do that with the A style or the B style type furnace, but now with this C model, we can able to do that. And literally what we're able to do is take a pipe within a pipe, if you don't mind, taking the bad gas out, sucking the combustion air on the inside part of that, whether it's a cone looking like this or a dome looking like that, or maybe a pancake style, but the concentric fitting is capable of working with this particular C style furnace now.
Fred, you know, we have some limitations to this furnace.
Okay.
One limitation is what?
Ooh.
We cannot do a
counterflow.
What? I can't turn this thing upside down.
Not today. Not today.
My gosh.
No.
How about, can I lay it on its back in a horizontal?
No.
Can I hang it on its face in a horizontal?
Probably not.
Wow. So we're limited to the capability of putting a left-hand supply,
Okay.
right-hand supply. If we do that, we have to do some things with the piping and changing.
Yep,
we're going to cover that in more detail.
It's all in the IOM, and there are some things that we've got to make sure that we manipulate and change because of the configuration that we're going to be going into.
Some of those things are the pressure switches. And as long as we're on this right-hand return, left-hand blow, right-hand blow, left-hand return, I don't need to move the pressure switch.
Exactly.
But if I turn that around, these switches are on the bottom, they have to be moved to the top. And I believe there's some configurations where we swap these 2 hoses out on that one pressure switch as well.
Yep.
There is a drain port right here. This drain port is very critical to be able to move any condensation that's coming from the blower into here. This is a small 1/8-inch tube. If this tube gets plugged up with dirt, rust, mud, whatever, that water will not drain, and what happens is the water goes back into my blower wheel, and it sounds like the Proud Mary just spitting water.
Yep.
If that's occurring, that typically happens about every 2 weeks. The problem is this tube coming across the bottom.
Okay, so we've got the electrical coming in over here on this side. The nice thing about that is that I have enough wires here to literally put it on the left-hand side of the box if my electrical deems that I can't get over there and I'm able to move that. One of the things about that electrical is that in this particular situation, we are a polarized type voltage. So the wire that is the hot wire coming from your plug has to go to the black wire of that junction box. Then, of course, it has to have a neutral, and then it also has to have a good ground.
What if I have knob and tube wiring in my house?
Oh,
like
I think you're in trouble.
Yeah, we cannot run these on knob and tube wiring. We have to have a ground wire that's present.
Yep.
It won't work with a ground wire. So we have our connections here, guys. The springs we talked about earlier are going to go in these 2 ports right here. And there's a count of turns. So we take this out, we take out the old springs, then we can screw in the new. And they're going to give you in the kit how many turns you adjust that to get your pressures. We have a manometer. The manometer is going to hook up to ports in here. We have our incoming gas pressure, and we have our incoming gas pressure here and our secondary pressure here. We got to make sure we have enough incoming gas pressure, and we can set the secondary pressure here on that process. What else, Fred, on this unit? What makes this new?
The model number says it's a BGH96. What does 96 mean?
96,000 BTUs of input, I believe, is where we're going to come into.
Well, this is my model number. It is a BGH96 080. So the 080 is the output.
Oh, you're right.
The 96 represents that I'm literally 96% efficient.
I'm backwards. You got it.
Which means that only if I pay $1 for the utility for the gas, you got $1. We had $1 yesterday or the other day, exactly. So if I pay $1 for the utility of the gas, I'm going to get 96 cents out of that dollar to heat my home. Only 4 cents out of that dollar is going up the flue. unlike our old pilot gas furnaces that may be 50 sensors going up the flue, or now the 80% furnaces that 26 is going up the flue. I'm only losing 4 cents out of that dollar, which is a pretty good deal.
It is. And so we have something new with the blower on this as well, correct?
I think so.
We have a constant CFM blower down here, which requires a different board and module over here crossing that process. So this is one of our first constant CFM products that we have.
Pretty excited about that, actually.
Yeah, that's great for airflow applications. Wow, you're magical.
Oh, up on a stand.
There we go. So there's a couple things we want to bring attention to here, Fred. There was a new sensor wire or a cable that came with the unit. We said it was a thermostat. Well, reality is it's for the outdoor unit of a Bosch IDS, and it's with the A2L sensor in play. So if this is an older system that doesn't require A2L, an R410A, then we could actually make those connections right here on the board. But if it's an A2L sensor where the A2L is going to shut off the outdoor unit, then we have to use this plug connector to make that up. And that's going to have to come out of the grommet here on the side as well.
Hey, I noticed something when you pulled this plug off. This is my common wire.
I'm assuming that would be it. That's black, brown. It begins with a B.
It does begin with a B. It's going to be the other B out there and the other B here.
No,
so
not B out there. That's going to be brown because we have a blue wire, which is B out there.
Well, that's black though.
Yeah. But we have black and we have a blue.
Yeah, but so we're going to, the common is going to be brown inside here, but black out there.
There we go.
Okay, all right.
We got a blue. What's the blue one for again?
I would say reversing valve.
How about the yellow?
That's just my contactor. That used to be the contactor. That's no longer a contactor that brings my first stage compressor on.
It actually runs a compressor and heat
all the
and
time.
cold.
There you go.
And we got a white wire. What's that white wire?
Man, I have no idea.
I don't either, man. We don't use that stuff. No, this is going to be our defrost cycle. This is our backup auxiliary heat. Purple, I have no idea for it. We don't have for it. So that's the connector that goes on that board, and we had that covered up. What else we got going on that we have it back up in the stand? We got our vent connections here, and what we're finding out is, again, we have to hook a hose up to here with a T coming off of here to drain this vertical rise out in this way here.
Door switch.
We do have a door switch, and this door switch, normally, if you don't read the codes through the glass, you pull that door switch off, your codes are gone. But this one's something different. What's this do different?
Well, new generation. So
like
now
you and me.
Yeah, really. So now when we open that up, we would think that we would be losing the door, the fault codes and thing, but I would have to power this up to see the LCD screen. And I now get to push a button here that allows me to see the last 10 fault codes.
And that button is right here beside the dip switches. That button's going to tell you what the last 10 fault codes, and it truncates, I guess, so after the 11th one, it wipes out. And if the first code is the most recent one. So you hit the button the first time, it is the most recent fault code that you get. First.
So in the process of installing this in the summertime, I'm in a hurry, it's hot, I hook up the electrical, I don't care about the L1 in the neutral, and I reverse those. When the polarity is reversed, this wants to be a heater in the wintertime. It is going to give me a code down there that basically says, hey, I can't work with that polarity reversed. I'm not going to light, but I've ran as a fan for the air conditioner, but I'm not going to light as a heater, and that's why we have to come back and make sure or reverse that polarity at that point in time.
So that polarity deals with our spark ignition. If we don't have the right polarity, we can't get the ground to create the spark, and that's where that fault comes into. So you have to have your ground and your spark. We have some sensors in here, rollout sensors in here. There's a rollout sensor on the side, high limit sensor here in the bottom. If you're getting rollout sensors, a lot of times that deals with the flue, the draft. If we don't have proper draft going up, if we have high pressure, water building in the box, we can build up resistance of air going through the secondary chamber, primary chamber, and out that flue.
Now, is the rollout sensor, is it a manual reset?
They are not. This is a, I don't think it is. I don't know if there's not. It is manual reset.
Oh, it's manual reset.
It is manual reset.
Okay. So that particular would have to be when that rollout sensor was tripped, my fan is going to run all the time. Can't turn it off unless I unplug the unit. And that's when Mrs. Jones is going to call and say, listen, my fan's on, blah, blah, blah. And the rollout switch has the safety has closed the circuit for the fan, and here we are.
Yeah, if she knows that, I want to hire her for an employee.
Exactly. She knows really well, doesn't she? So absolutely. Absolutely.
The high limit in here is auto reset.
Yep.
So just the flame out is manual reset.
What would cause that high limit to trip and open up?
Well, there's a couple things can be there. One is the irregular gas pressure or higher gas pressure than what we should have.
Okay.
Our biggest issues are when you convert this from natural to LP, you have to adjust your gas pressure.
Okay.
And so if you fire off at 4.5 on low and 10.5 on high, and somehow you go back to natural, you would have a blowtorch in there. It would be very radical.
Yep.
If you have a dirty filter, if we don't have the proper airflow going through the system, if we would choose the wrong fan speed, and guys, something new on this one is we have one replacement board. So in the future, if you have to replace the lower board, that one board fits all of our units.
Look at that. Okay.
And you have to choose the proper CFM for that unit you're sizing. If we choose a 60,000 BTU Vertus and a board setting and it's 120, we're going to have half the airflow.
Okay,
and
wow.
It'll be popping
Okay.
off on high limit all the time.
So in this particular furnace, if my filter gets dirty and my blower wheel gets dirty, and I start the process of having the capability of not blowing the air through the ductwork like I needed to go through, that secondary heat exchanger is first in line to the coil that we're fixing to put on here. So that would get dirty also, right?
Oh yes, and they're hard to clean. They're hard to clean.
Oh.
If you have an issue with combustion, if you ever get to a point where you see a lot of carbon in here, probably the gas pressures weren't set up right. You're starving the burner air. And honestly, you might have to change that secondary chamber. I'm not sure you can clean that.
Yeah, wow. Okay.
Hey, one of the other things, Fred, we talk about is our temperature rise across the coil. So when we do a temperature rise across the coil, we never want to be below 30 degrees of condensation or over 60 degrees because we could crack the heat exchanger.
Okay.
So if I take my air sensor and I come in from the side, I'm going to be 30 degree here, maybe 20 or even 10 degree rise. You think, man, we're way under, crank that gas pressure up.
Yep.
If I come back here over to 4 tubes, right here in center, I can be upwards of a 200 degree rise. So when we're doing our air sample, our air temperature rise, we want to be out of sight of these elements. So we want to be up here around the corner of the ductwork. We don't want to have that thermometer be able to physically see that infrared tubes. Because the infrared tubes will give you a bogus reading.
Okay.
Come in from the side, you're reading the secondary air. So we got to blend that all in to that process.
Right.
So what if I'm over 60 degree rise, Fred? What would you suggest that someone do if they're over 60? Let's say I have a 90 degree rise across this unit.
You probably need to look at your static to make sure your airflow is correct.
You'll have to increase the airflow.
Okay. You might also want to take a look at your gas pressure.
And drop the gas pressure back a little bit if you have to.
Yeah.
Correct. So that's an awesome feature.
Do I call the gas company to do that?
Sure. They won't come.
They won't come.
Don't care.
No, they won't come. No, they won't come.
So that adjustment is done right here with the manometer. So again, when you do your gas pressure at this port, we're going to hook here with our adjustment, and right here is where you hook that manometer into this port. You loosen that up a hair, and then you put a hose over top of that and you read it. You don't need to take that out all the way.
Exactly.
But when you're done, make sure you snug that back
exactly
up.
right. Or you're going to smell some gas coming out of that.
I wonder if the E2L Central
I
pick
don't
that
know
up.
if that will do that or not. I don't know.
So we do have our primary adjustment over here. We got to make sure that we have. And Fred, I don't know if you've experienced that issue, but there's been times with people with LP that have problems with it lighting. One is in real cold weather when your regulator's not big enough to handle that boil off. In one case, one of our other trainers had a real issue with. Every morning at 10 o'clock, every Saturday morning at 10 o'clock, they had a flame out issue, flame problem issue. He happened to be there at 10 o'clock on a Saturday morning. It's when the generator kicked on, it lowered the incoming gas pressure enough to not let it combust properly.
Oh my.
So the moral of the story is, I guess you probably need to check gas pressure with everything operating inside the home.
Yes, sir. Yep, absolutely.
Generator, furnace, stove, dryer, anything that pulls gas to make sure that this is going to be functional for you.
Okay. Hey, good stuff about this new 3rd generation BGH furnace from Bosch. Let's take the coil that's now going to be set on top of that, and let's unbox the coil.
All right, we can do that. I'll bring that coil over to you since you're old, okay?
Oh, I'm old. All right. Snap our finger.
We had it a lot closer, but somebody moved it.
I know, somebody moved it. Why do you move that thing for like that? We get out our TSA approved knives.
Hey, I want you to know that you got a toad sticker. I just keep a small one.
You never know what you're going to run into down here in Oklahoma.
Is that people?
Yeah. So what we have here is a BMAC 36.
What's that mean? That's a 2.5 to 3 ton.
Either or.
2.5 to 3.
That's awesome. Upside down for trash.
Is there any?
Oh look, it's backwards.
They gave us a manual.
Why is it backwards?
It's upside down.
Oh, hey. Let's take it off of this.
We're gonna have to put it up on there anyways.
Yeah,
right?
we are. Let's take it off of this.
Chris Penn, why don't you come in and give us a hand, Chris? So why don't you grab that end for me, Chris, and give us a hand. You know, Fred's old. You know, we don't want to put him under the gun here too much. He's senior citizen today. It's the wrong size. Just set that on the
I
down
noticed that when I saw the model number a while ago.
All right, so this is an application. This is an application we talk about a lot of times, guys. You should check the model number of the unit and here to make sure the thing's going to match up. But we can still talk about the concept. It's still the same at this point.
So what we have is a C-width furnace and a B-width coil.
So it's not a fallacy. There are dimensional changes.
Absolutely. Okay. Absolutely.
B's a B, a C's a C. And we're not D.
Still here. Yes, sir.
What's this for here, boss man? What is this all about?
Is that extra?
I think it is.
Oh.
I can't hear nothing.
You can't hear anything?
No, I can't hear anything.
Look at this. This particular coil is the new refrigerant, the 454B, that is going to match up with our 454 IDS-B unit.
Do I have to put the 454B in January 1 of 2025?
Probably.
We don't, guys, we have to have a new construction, anything past January 1 is 410A, but we still can install a 410 unit through the year of 2025. But come January 1 of 2026, it's got to be. It's got to be. And guys and gals, questions might come up, well, why can't I use my existing case coil I have now? Because the existing case coil for our 454B will not have the sensor.
Exactly.
And it's a liability issue if you don't do that. We can uncrate that and show them the sensor real quick if we want to take the screws off. It's made for rattling, so you know it's rattling.
You know it's on.
Wow. First off, I want to comment about our case coils. Look at this case coil. 1, 2, 3, 4-row case coil. A lot of times there's some complaints about Bosch's air handlers may being a little costly or case coils a little costly. We don't have a 2-row coil, we have a 4-row coil. The 4-row coil enhances our dehumidification process, our heating process, and cooling process. So we have our A2L sensor located right here. And that A2L sensor is good to go. If we turn this from a left-hand return to a right-hand return, we'd have to move our sensor to this side of the coil. We want this sensor to be on the bottom of the coil if we're going horizontal.
Okay. So what's the sensor do?
It's senseless.
Okay.
So it's an infrared sensor that senses a refrigerant application. There's a leak involved to this sensor. So what that sensor is going to do is send a signal through this wire, which plugs into this board down here at this white connector right there. And that board is going to say, hey, I'm shutting off my furnace if I have the furnace running. I'm shutting off my compressor if I have the compressor running. And I'm going to bring the fan on the high speed. So that rationale for this harness, in the old days, we would wire directly in here. But now this is going to shut off that compressor section. So when there's a leak, we don't have any compressor to build more application. That is an auto resetting sensor. You know, Fred, just like you and I, it has limited lifetime operation.
Limited.
Perhaps 15 years, 10 years. And the sensor goes bad, it'll give you a signal on the board to indicate the sensor needs to be changed.
Awesome.
So that will be changed down the road. We have multiple pan connections. Why is that in there for?
Different configurations.
Okay. So if we're doing a left-hand return, that puts this down here on the back. Now something that's kind of come up, and guys, again, I'm gonna do this just because I can. Let's spin this coil around momentarily.
Spin it totally.
Yep, 180 if we can. There we go. So the issue comes up sometimes with left and right hand return. If I do this with a left hand return, normally my fittings are now out the back.
Right.
I have to make my connections out the back.
Right.
All it requires you to do is you can actually move this 2 bracket here, 2 bracket here. You drill these 2 holes down here. You drill these 2 holes up here, and you can change the coil inside the cabinet. And it keeps this on base on flange,
right?
Not flange on flange,
right?
No Z-strip.
Look at that.
And you don't have to have the connections out the back. If you're in a knee wall in an attic, you may not be able to get out the back.
Yep.
So guys and gals, I don't think this is in the manual, but if you want to make that conversion, you'll have to require 4 additional holes, measure down, get this one, then you can actually flip that coil around
inside the box.
Inside the box, and you've got that now for left hand or right hand, base on flange.
Wow, that's
Let's
awesome.
turn it back around.
Right.
So something that just brought up to us in this application, you never want to put this in front. And I've not seen it, but I guess in parts of the country, maybe it's happening, that we come out the side because there's a chance of melting that condensate pan. Fred, you know, on page 10, paragraph 3, subarticle 2, it claims that we really should not put this pan on a oil furnace.
Yep.
And the rationale is it could melt. The rationale is that if we have a red hot refractory and we lose the power with the snap of a finger,
yep,
all that residual heat's going to go in there and rise. And when that residual heat comes up and hits that pan, the pan's probably going to do what?
We're done. We're going to melt.
We're going to melt. And we have a new humidifier system in
there. Yeah, there we go. there we go.
So we're going to recommend an aftermarket condensate pan on oil furnaces with a 6-inch elevation above the heat exchanger.
Okay.
If we're not to 6 inches, there's a chance, and probably never going to happen when the unit's running, but in the opportunity there will be a power outage, and that residual heat would stay.
Yep.
It'll melt.
Yep.
Is our pan anything different than anybody else? No, they're all plastic. We just bring it to their attention. So we're trying to bring all the fine points out that you can expect if there'll be a problem.
Right.
We'll bring
Let's turn it back one more time.
Yep. There's kind of a halfie. Okay.
So 4 rows, all aluminum, TXV valve already installed, fixed. How do I clean that coil if it gets dirty?
High compressed air. So we're going to clean this coil because this is a hydrophilic coating. Hydrophilic, one back, is plastic and water. That's why it's hydrophilic.
Okay.
These coils do not like UV bulbs. You do not want to put a UV bulb in the air handler where it shines down on that coil.
A direct top shot.
It'll burn that hydrophilic coating off. Does that mean the coil is junk if the hydrophilic coating goes? It is not junk, but you're going to lose that water beating capability to remove that process. Fantastic 409, simple green, a garden hose would be the proper item to do. I'd stay away from anything that's acidic or high alkalinity to go in and clean that coil.
Okay.
And really, if you're cleaning the coil, what does that tell you, Fred?
Somebody didn't clean the filters.
Changing the filter, maybe not putting the filter in correctly, or this has happened sometimes. Mrs. Jones goes to get a filter, she forgets about it, she doesn't find one, and you get a call that we don't have any air conditioning, and you find that she didn't put the filter in for a year ago. So that'll be an issue with the blower wheel, the coil, the secondary heat exchanger, and now our case coil, A coil.
Wow.
So we have our fittings up here, and these are short. And when you braze these in, you have to be very cautious that we don't cook inside. Can we go ahead and pull that off just for steak and beans, Fred? Yep, I have it.
You do. Let's do that.
Let me do it. Now wait, before you pull that red tip off, what does that represent?
I wasn't going to pull the tip off.
What does that represent? These coils should be
sealed and filled with nitrogen.
Yeah, not propane.
Not propane.
Not butane.
Not air. No. Just nitrogen.
Not 410A.
Not 410A.
454.
Not 22.
Wow. So there's our fittings are inside, and the issue gets into when you braze, you have to wrap these with a rag and protect the inside. When I do my stuff, I'll slide this all the way over to the line set. That gives this wide open. I can do my braze. I am a turbo tip person, not oxygen acetylene.
I'm sorry.
So, well, it's good. So you got to watch your heat. Those are flamethrowers.
Exactly.
But,
exactly.
And this is brazed in, as our manual says, braze.
Okay. What happens if I got one of these machines that will automatically just mash a fitting into that?
That's usually a problem because our swedge doesn't allow that to fit.
So I can braze
You could braze a nipple and
There you
then
go.
do your process. And for those people who are having fire watch applications in some larger cities,
Yep.
you're not allowed to braze inside a structure. Braze this on at your shop, and then when you get on the site, you can do all mechanical
Oh, there you
fittings,
go. Okay.
And you don't have
Yep.
to worry about
There
the
you go.
fire watch
Yep.
condition at that point.
Yep.